see it on your screen, you need to do it through like a remote desktop. So, so it would be a pain, but it brings up
I mean, we can run Windows Server on them and
use
Windows drivers.
That's true, yeah.
But again, we were talking about this last time. The length of time it would take the picture to actually come to you over the network is
that's
absurd.
painful.
So, are you ready to record? Can I go? All right. So today we're going to be talking about supercomputing capabilities that we have at CMU and that we can provide as a resource in general, how to access them. Okay, it's not switching slides. There we go. So today what I'd like to talk about to start with is sort of the structural overview organizationally and how you get access to these resources, the process for getting an allocation, getting your user ID, and direct you to how to find the resources that you need after you've done all that. It's a fairly new system. It operates like a marketplace where you can buy credits from different supercomputers. I'll be concentrating on the Pittsburgh Supercomputing Center since that's the one that's most closely related to us. And that's also the one where we have direct contacts for technical support and user account maintenance. And then I'll show you a couple examples of how to actually use these. So this whole supercomputing initiative is sort of a federated idea where different people could access different resources. Started back in 99, 2000. And at that point, it was called TerraGrid. That was the first effort at this. And that was an NSF-funded initiative that lasted for 10 years, which is pretty good. It was originally slated for 8 years, and then some groups pushed it, and they got an extra 2 years out of it. So when that funding dried up, they started a new organization called Exceed. And I can't remember the exact acronym for that, but that lasted for 11 years. And it just ended on September 30th, the end of September. And so we just started with our new system, which is also NSF funded, called Access CI, which is Advanced Cyber Infrastructure Coordination Ecosystem Services and Support. And then they added the CI on the end as cyber infrastructure, which is a little bit redundant, but I'm gonna let that go. So that's the organization that provides account management, passwords, allocations for supercomputing. It's the group that you have to petition to ask for more resources. And there's similar other efforts around the world. This is a US-based one. The Open Science Grid is worldwide. The European grid infrastructure is a lot of universities and organizations in Europe that provide a similar authentication and allocation structure. And then there's other independent organizations like the National Center for Atmospheric Research, which is, I think, at Boulder. Is that at Boulder? Yeah. The interesting thing is that a lot of these, even though Access CI is an umbrella and provides access to a lot of different supercomputers here, they peer with these other groups and independent institutions. So in many cases, even though you might get another allocation separately through here, you can use your same credentials from Access to log on to these other resources. So this has been a big change 3 weeks ago. I'm still adjusting to it. The team at Access now, which is transferred from Exceed to Access, is still adjusting to it. Usually we have somebody from Exceed come give this presentation. So they are busy adjusting to all these new things. So I'm going to include his presentation a little bit later and sort of stumble through it. The one thing that I want to note that is different here, and we've only just talked about this recently, if you use these resources, they do ask that you credit them in your acknowledgements for your research. On the web page for Access, there's a very specific way to acknowledge the resources that they've used. And if you're coming from Exceed and you've used Exceed resources in the past, there's a different specific way that's in the same paragraph that tells you how to credit them. So if you're working on PSC right now, and I'm talking to all of you people out there, you will want to look up how to credit or usage of it. So there's 5 basic steps, Some are a little bit easier than others, but it's much easier than in the past. So I'm not even going to talk about the past. We're just going to move forward, and you're going to forget everything you knew for the past year and a half or 2 years, however long you've been using PSC. But basically, you create an account, you select your opportunity, which is your resources, you request an allocation, and you get your credits, and then you go actually buy the resources that you want. So even though you've selected what you want to do in the past, you want to make sure that you get the specific resources right there when you exchange the credits for use. So I'll walk you through each step of this. First off though, who can use this? All right, this is a big question. Faculty can obviously use this. Any faculty in the university has direct access to this. In the past, we've had only graduate students with an NSF fellowship. So you have to have gotten NSF funding yourself to be able to do research on the systems. So we started doing something where even if a faculty member wasn't necessarily doing the research with the student, they would get an account and they would sponsor a student under them. So the faculty would be the PI and the students would just have to sort of jump from faculty to faculty maybe, come on my allocation, whatever they could do to, if they didn't have an NSF fellowship, to get the supercomputing resources. But now, just plain old grad students can use this. You don't have to have a fellowship, you don't have to have a faculty PI, you can be your own PI. And that's so cool, that's like a huge step forward, right? So the only thing that you'll need to do, I'll walk you through the process of getting the allocation and getting that set up, but the only thing a grad student needs for some of the intro level resource chasing is a letter from their advisor. So as long as you have a letter from your advisor, you can submit it as one of the documents in the process, and they'll consider you just like a regular researcher. So this is like a big step forward. So I've included at the top of most of these slides a URL where you can go and interact directly with whatever we're talking about, so you can follow along with this if you want to get started quickly. There's 2 notes. If you are a previous Exceed user, you don't have to sign up for a new account. You can activate your new Access account by, when you get to the account registration screen, choose Access CI. You can type in here, like I did, Carnegie Mellon University. That is a separate thing. So if you're already using Exceed, you'll want to use Access CI and your credentials for Exceed. For all of the new people, you do want to choose Carnegie Mellon University. And when you do that, it will take you to this screen, and it says, blah, 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 begin. And subsequently, you'll see your friendly web ISO screen, your web login screen, whatever you want to call it. We've all seen that a million times at CMU. Once you log in there, it'll automatically fill some of these, occasionally, not always. The thing that you want to watch out for is that mine automatically filled to @stat, so it actually chose my preferred email address from the university's directory. So I had to go in and manually change this to @Andrew. I would recommend that you use @Andrew addresses here, as opposed to any other email address. That just keeps everything very seamless for you. And that will carry on to sort of the next iteration, probably 10 years from now if you're still using it. You can see over here, there's just a set of steps, just like any other web system you might have signed on to. So we're collect petitioner attributes, which means you're the petitioner, you're asking for resources. Enter your name, your email address, just like you're signing up for, Facebook or whatever. You submit, it gives you a message that says it's not complete, go verify your email, just like any other web service. You'll get an email almost instantaneously. Again, contrasted with the previous process where you had to wait for a human to actually approve your account. So this happens, at the drop of a pen. So it walks you through that. Email confirmation, wait for confirmation, confirm email address, agree to terms and conditions. It's the same as iTunes, right? Then you go and you can actually, these are sort of obviated steps. They take place without you interacting with them. After that, you select your opportunity. I'm not going to talk about the past, like I said, I'm just going to talk about the future here to not confuse anybody. But there's 4 opportunities. explore, discover, accelerate, and maximize. Explore is if you want to explore this, literally, just play around with it, see if supercomputing is right for you. If you don't know what you're doing, this is great. 400,000 is sort of the upper limit of what you can request at that point. The default for a request used to be only 150,000. So not only have we made this process easier, there's a lot more credits available to you.
Are they about the same value? Is one of those new credits about the same as one of the old?
I will talk about that in a second. Yes.
Because if they are, that's a huge allocation.
It's a huge jump. And I don't know if it's caused by people not using it enough in the past, or they're just trying to get more people in general across different universities. But that's, again, part of what I'm going to talk about. So as a student, you can probably just get a letter from your advisor, go sign up for an Explore allocation, and they'll probably give it to you. You know, you might have to have like a paragraph of what you're doing with it. I'll show you exactly the screen where that gets entered. If you're a little bit, you know, moving ahead a little bit more, say your ADA project's going a little longer, say you want to get started on your thesis, then you'll probably choose a Discover. If you're a faculty member who has a very specific project that's sort of wider ranging, you're not sure what you're doing, but you know what you're doing with your code, you'll probably apply for an Accelerate grant. I'll show you the differences in a second. And if you're doing something really huge, really special, then you'll go for the Maximize. But I would highly recommend starting from the bottom and moving up. No problem with that. So here's a little matrix of what the differences are. And these sort of purposes are what I've been talking about. But to give you a little more detail, so the general allocation duration is 12 months. And at the end of 12 months, or the end of the grant that's working with your research, you have to submit either an extension or request more credits if you run out in the middle of the project. But it's, you know, a year is a good time frame for that. The other great thing is that for these first three, they accept applications continuously. There's no waiting process. The Maximize grant is only every 6 months. And so one of the big differences here you'll see is for Explore, you only need an overview. You need like a paragraph of your research. For Discover, you need a one-page proposal. And I should note that that's maximum 1 page. Don't feel like, oh, they need at least a one-page proposal. They won't read it. They'll just send it back to you. Same thing for Accelerate. That's a 3-page proposal. So you can see we're growing a little bit every time. Maximize is 10-page proposal. Generally, you do need a grant for that. You don't absolutely, but it, you know, helps with your case when you're asking for a particularly large allocation. And so you'll see the different sort of judgments that go by. This is for the lower end, you're just confirming eligibility, like you're part of the university. Do you have a project? Yes, okay, you pass. All right, same thing with Discover. They sort of just look at the detail that you've put in and see if you've done any exploration beforehand to know that your code's gonna work in this situation. When you get to the higher levels, you actually have a panel of people reading it. It's not one researcher just check marks and says, you know, go on with this. You'll have 5 or 6, maybe 10 people reading your research proposal.
Again, just kind of comment and ask, I mean, this seems like a huge step forward, like this is like doing so much better than what it was, but is there some fine print here, like for example, like, do you need to have an NSF grant to have access to this, or like, can anybody at a US university, you know, who just gets a letter from faculty, you know, get, you know, these allocations?
This is for graduate students, so the MSPs or the PhDs would qualify for this. You do not need an NSF grant, except for probably in the Maximize section. Yeah, because that's primarily grant driven. And when you get to Maximize, I should note that they do want results. Like they want you to send a write-up, not just an update, but an actual progress report. When we're talking about these low levels, progress reports tend to be a paragraph or a page. So it's very low key if you want to add another year to your allocation or ask for more credits.
Yeah, this looks so much better than my question before.
Mm-hmm. Oh, and the process is much easier too, the interface. I'll show you that in a second. Right, so to request an allocation, you need to gather an overview, just like we talked about, and your CV. So you have to have a CV for yourself if you're a student or a professor, right? And any co-PI. So if there's somebody else working with you on the project as a PI, you'll need that. If somebody, like a grad student, is a user in the system, you as a PI, whether you're a grad student or a faculty member, can just add that person to your project. They don't need a CV. They can just work with you. That brings me to my other note. For new people, I highly recommend just going and getting your account set up. That way we don't have any waiting, and if you want to work with somebody, they can just add you to their project. You can just go in and request it. So I'd recommend some point this weekend just signing up for an account here, making sure you're registered. And then these are the other three things. So just to get started with the lower level grant, you need a title, you need some keywords, and a field of science. So whether it's machine learning or astrophysics or genome sequencing, whatever it is. There's some in there that you can choose from. But again, think about also bringing the abstract in, because that'll help you get rubber stamped in very quickly. All right, so once you've requested your allocation, okay, it's very strange. Once you've requested your allocation and they've approved it, you will receive your credits, and then you have a bucket full of credits that you can spend in the new marketplace. In the previous model, you had to be very specific about the resources that you wanted in your allocation. You do not have to do that here. You can get your allocation. It's basically the concept of being approved scientifically rather than being approved by a resource provider. So think of yourself as having an actual statistician approve your project instead of somebody who's working on the servers. Right? That's a big difference. So you get to go exchange your credits. To Mikhail's point earlier, there's an exchange calculator. So I'll show you that really quickly here. So say I had 1,000 access credits. I could choose whatever system that I was interested in working on. Say I want to go to the Texas Advanced Computing Center and use their Knight's Landing Skylake system, whatever the resources there happen to be. I only have 56 units there. So this must be like some specialized system. But if we look over at PSC Bridges 2, for example, which is the one that we generally use for a regular thing, 1,000 is 1,000. Let's see, so SDSC Expanse GPU, for example, you get 19 service units. So they're not, some correlate to CPU hours, some correlate to hours of GPU usage. If you go to each organization's website, you'll see the specific policy on that, but this is a quick calculator. All right. So what do you get for your hard-earned credits? Okay, so there's a list here of some of the participating universities and organizations that directly connect to Access CI. But if you look at this web page, you can see here's a whole list. Click on any given one of them. I'm curious about that. It's Knight's Landing Skylake system. So what's there? Then it gives you details on everything that's in that particular resource. So this one, for example, has each node there has 68 cores, 16 gigs of RAM, MCD RAM? I don't know what that is. 96 gigs of regular RAM and a 200 gig hard drive in it. And it gives you a nice little URL, so if you want to actually visit their website, you can, oh, Exceed is gone. They didn't update the URL. Nuts. We can just search for attack and it'll take us there. Eventually. Yeah, so this is another example of one of the supercomputers we have access to through Access CI. There's, like I said, there's SDSC, TACC. They all have different sort of qualities of GPU, different numbers of CPU, different number of nodes, different policies on fair use scheduling with your job, or how many CPUs you can use at once, how long your job can be. I'll talk you through some of that with PSC specifically in just a second. But you can go dig into their web pages and see exactly what those things are for yourself if you're curious before you try and exchange your credits for use there.
So like once you have those credits, like why would you decide to go with PSC, for example? Like is there any further benefit for us to go with PSC versus some of these other institutions?
Yes, so PSC will almost 100% let you on their system. So once you exchange your credits or attempt to, your credit exchange has to be approved by that institution. So PSC will almost always say, yes, go ahead, we need more people on, please come here and use us as your primary resource provider. Texas is very high powered, similarly open. They'll probably let you on pretty easily, so will SDSC. I don't know about the other ones. But like I said, the difference between them is hardware. So if you're having some kind of weird parallelization problem, you might try it on another center. We haven't run into that yet. But if, again, the other case is that if you were trying to use GPUs, and because you used 2 days worth in the first time you used it, the fair use scheduler there will actually bump you back in the priority list. So you could maybe go work on another set of GPUs. But again, that requires moving your files around from system to system. Some of them share storage. There are a lot of details here, and I'm happy to sit down and walk anybody through them. But all the policies are public. They're published online on everybody's website. Access has some of their own policies. So, you could spend days reading through these, which I have, but I'm not going to talk about that right now. Yeah, so that's what you get for doing a 5-10 minute application process. You get all of that. That's great. So, with that in mind, I do want to jump into PSC Bridges 2 specifics. So PSC is the actual group, the Pittsburgh Supercomputing Center. All of their servers are out in Monroeville, far away. The staff who runs it are over here on Craig Street. So if you really wanted to, you could go knock on their door and bother them. They don't like that, but they do respond to email very quickly. So you can go ahead and look at their site at psc.edu. If you have a project going, and I'm not sure if they prioritize like the maximize access group first, or if they'll share knowledge equally with explore, discover, whatever. But they do have free consulting personnel. So one of the advantages to using this center, it's kind of where I'm trying to get my level to, is that if you're working on a problem and you're running into either, my program's taking more time than I thought, or it's not working at all, what am I doing wrong? You can put in a request and you'll get a person to talk to you and read your code and help you fix it, or help you develop it. You never know how much time they have. But they are generally also scientists or statisticians, so they're not, I'll say, technical system administration people like me. They're people who work with code in a scientific capacity regularly. For a quick intro on what Bridges offers, there's a URL here. It gives you a whole rundown. It's got a user guide. It's really nice. They've improved it over the past couple of years. So this is the part. Oh, sorry. Yeah.
So it says your allocations at psc.edu. So is this going to just directly to Access, or there's even some separate allocation process for PSC?
Let me see. I can't seem to jump out of here. Okay, so let's see. I'm going to log in here. The wireless network is great. Now here we go. Okay, so this is CMU MCS Physics Cosmology. Okay, this must be a remnant of a past presentation because this does not have my information in it. I will take that out before we send the slides out. No, all allocation stuff is done through Access, not through PSC. So I'm not sure what that used to link to.
So
Yeah.
what's free and what's not free? And
I'm going to get to that because that's like the highlight of the next presentation, the next
Okay,
portion. Yeah. So this is usually presented by Stephen Deems, who's our man over there. Like he knows everything, he knows everybody. If he doesn't know, he can connect us with people who do know something. So he starts off usually by saying this is a joint venture between CMU and Pitt. It's not technically it's housed in the Mellon College of Science, but it is an independent NSF-funded organization. So a lot of people think, oh, it's over there, it's UPenn, I can't use it. Or a lot of people think, oh, it's at CMU, I can't use it. No, everybody can use it. Like, everybody can use any of these resources as long as they let you on. Oops, not playing. Okay, so this is his whole spiel. PSC is a cyber infrastructure provider, and they really just want people to use it. They want to give you the best service. They want to provide the best servers. They want to do everything the best. They are more than willing to take your feedback and help you with trouble you might have using it. Like I said, they have people to help you with your code, but they also have people just sitting there on the phone as a help desk. You're not calling another country, you're calling Craig Street. They will be happy to help you say, oh, here's how you SSH into it. Right? I can do that for you too, so I'm good first stop. And I should actually talk about that just for a second here. I have a title as Campus Champion, which means I have a little more access than a standard researcher does. So I have my own allocation. I can add people to that to get them onboarded quickly. I'm also a direct line of technical support to them, so I know people over there also. So I'm able to help with any of your issues. I actually just okayed another student on campus to be a campus champion. So now we have 3 campus champions at CMU. And if one of us is busy and you can't get the help desk, then you can go and actually email these people. So I can put that information on the computing wiki.
So who are the others?
Somebody is in electrical engineering, and then the other is a student who just was interested in it. Yeah, I got a message from the provost saying they submitted this application, we have no idea what to do with it. Yeah, so as of last year, they were running research that was backed by $100 million worth of grants. So they have a lot of heavy investment. They're not closing anytime soon, they just have a new project. And I sort of ran through all this earlier. Yes, so this is a 24/7 system. There are people manning support 24/7. It is a help desk, so your ticket goes in. Hopefully you get a response quickly, but they are there. If you have to, you can call them. Their contact information is on the website. All right, so what is PSC? It's a place to get science done for free. So everything's free. That's the bottom line. This is the most exciting part. He gets a big rosy grin on his face and says, just come and use it. It is a shared resource. So because you're not paying for it, you do get a managed environment, right? So with all these projects going on, you do have to be patient sometimes. Maybe your job doesn't run as soon as you set it to run. There's a couple job restrictions that I'll get into shortly, but it is a community, so etiquette applies. We want to be nice to people. We want to ask for help nicely. If you've ever done tech support, you know how it can be. If angry, irate people who can't get their computing done and their project's due tomorrow, you know how that can be. So we're all looking to help each other. And yes, so as I said, we're in the 30th year of this sort of cyber infrastructure project, and before that, they've been working as a team for years before that, getting these grids set up, getting experience behind different computing environments. And this is something he could probably speak better to, Stephen, but they will help you with your code. They're not going to do your work for you. They're not going to do your science, right? So they'll get a basic understanding of your project and what you are getting in, what you want out. They'll guide you, but they won't write any code for you specifically. I don't know what a regional network provider means, so I'm just going to skip that. Okay, so it's not a cloud service, right? So our cloud service, like we talked about with Azure, we can go spin up a virtual machine or a number of virtual machines. You can arbitrarily decide what you want to do with it. It's great, it's magical, it costs a lot of money. This is free, this is stable, this is scheduled. has a few features that the other ones don't have, like everything's built in. You don't have to do any system administration yourself. They're also not for profit. They're never going to ask for money from anybody. It's free now, it's always going to be free. PSC, again, is primarily dedicated to serving Pitt and CMU. Just like any of the other supercomputers, they'll allow outsiders on. The bar for entry is a little bit higher. I should also say, and this is something I learned this past year, when they say as well as our region, besides national research, they work with high schools, they work with a lot of different organizations in the area and across Pennsylvania for a lot of different initiatives. So it's not just research level, or sorry, university level. It's full educational and scientific research. And they're just like the rest of us. They use Stack Overflow and Google. So don't expect them to know the answer to everything. And then this is a selling point. They want everybody to use it, whether or not it fits you necessarily. Okay, so we have a whole lot of computers over there, right? This is sort of what I was pointing at earlier. They have specialists working in all of these different areas, more than this, ... So you can probably find the expertise that you need if you're having trouble. And this, it's not even necessarily with your code. It's like, oh, I have this problem. How long should it be running? How many nodes should I use? How can I optimize this job, right? Maximize my usage. So there's sort of like larger questions that you can get answered to rather than just digging down to the nitty-gritty of the code. So for the training, they do have regular courses that they teach. They're usually hour or two long sessions. Sometimes they're a full 6-hour day in case of the big data session. We used to host them here before the pandemic. And everybody kind of sits around and does the workshop with the trainer. So if you don't know anything about MPI, they offer MPI training courses. You can come out of that with a couple of simple scripts to run your MPI jobs on PSC. It'll save you probably a couple days or weeks of actually learning it yourself. So they have a training section of their website that will outline upcoming opportunities, which again, I think they're still building since we've switched over to Access. And then I highly recommend checking out the user guide too, because that gives you very detailed intro instructions to how to run jobs on some of the different types of nodes and what the differences are on the scripting capabilities of each one. Active Research Awards. Okay, I don't know that one either, so. There it is. So, I don't know why this is taking so long. This is so weird. No. There, okay. So these are all a number of the research partnerships that they have going on with outside organizations. So they serve individual researchers, but they also build up, multi-million-dollar partnerships with other people. So some of the projects that they host and some of the data that actually gets generated stays there. They actually have a data repository there. So these are some of the projects that they've been very interactive with in terms of training and consulting and everything else. So the configuration is the cool stuff, right? So what do we have? We have 488 nodes with 256 gigs of RAM in each one. So that's a lot of memory. 16 nodes of 512, and if you go to the extreme memory, you get 4 terabytes of RAM per node. I had a allocation on that, and one of our new students used it all up in a week. So I don't have another allocation for that right now. Let's see. And then the GPUs. So the GPU, we have actually 24 nodes with V100 GPUs, and they've been in there for, I want to say 3 years now, and they're still very relevant. So these are like really useful for GPU computing. Again, one of the reasons that people use our Azure system for GPU computing is because you don't have to wait in a queue, right? So it's yours, your machine, you can do whatever you want with it. This is not actually that heavily used. So if you want to get into GPU computing, I would highly recommend taking a look at this as a resource. Yeah, and they keep sort of adding on machine by machine, and that'll be listed on their webpage as they add different ones. And then we have storage. So there's a 15 petabyte disk. So along with your computing allocation, you actually get to buy however many storage credits you want as well. I think your default is probably like 500 gigs or something like that. I don't know what it is now since they switched to access. But they do have a tape backup system as well. I'd recommend just backing up your code on your personal computer rather than relying on them recovering it. Yeah, so this is his summary. It services everybody, just like all these other centers. Free. Yes, so this is a good point. So you actually apply through Access for your allocation, but if you're choosing resources for PSC, they will, this is his emphasis, they will rubber stamp it more or less. As long as you're approved by Access, they sort of take it as, oh, this has scientific validity, so let's bring them on. Yeah, and so you might run into people that you are interested in their research, and they might be able to help you out with yours. And again, that's his sales pitch, so if you want to talk to him directly, he's happy to talk to you. This is a good address to reach him at. Okay, so what does Bridges have? There's a whole page that lists like all of the software packages that are on PSC. These are some of the more relevant ones for us. You know, Anaconda, CUDA for NVIDIA, GPUs, Jirobe, Julia, Jupyter Notebooks. You guys all know this at this point, or you will soon, I should say. It also supports Singularity containers. So if you're familiar with Docker or Kubernetes container technology, Singularity is an open source container technology, and that's the reason that they only do Singularity, because they don't want to mess with anything proprietary. That said, Singularity is a little more finicky and more intensive in setting up an image, so I haven't gotten around to it because the steps are just a little much for me right now. The other cool thing that they have is public data sets. So if you just want to goof around, explore with code, but you don't have a project, you can use their public data sets that are on their storage. And there's a whole listing on their website again of exactly what those are. Right, so here's a very important note. You have to have an account for Access CI, but you also have to have an account for PSC. So once you get an allocation through PSC specifically, they'll send you another note saying, make sure you set up your user account. It's a similar process, it's very straightforward. Once you're on there, you'll use your PSC credentials to log in directly to the PSC servers. Okay? You don't have to go through Access CI except if you're managing your allocation. That said, you can see your allocation and your usage when you're at the command line in PSC. So they talk to each other, but the authentication is done specifically through PSC for computing. So there's 3 different methods of use. Interactive sessions, which is just like what you do with the Hydras or on your computer. You log in, you start an interactive session, and you can type away at the command line. The whole time that you're using an interactive session, it is charging you credits per hour. Okay? Then there's batch mode. So it's basically you SSH in, you have a little script that I'll show you in a second, and that will run your code or your scripts. And then you sign off and it just does it for however long you set it to. The default for the regular nodes on Bridges 2 is a maximum runtime of 48 hours. So that's important to know, because a lot of people come in and maybe their code's not optimized, maybe they don't really know what they're doing. The code will just stop at 48 hours, and then they'll come back and they'll say, what happened to all my data? Where's my code? Like, what's happening? In that instance, there are, the extreme memory nodes actually allow you to run for, I think, 192 hours. So there are differences between what's called the partitions and you can read about this all in the user guide. I'm not getting too in depth right now. But you might find another supercomputing center that has a wall time, which is what the 48 hours is called, that's longer than 48 hours. I haven't found it yet, but you might. And then the final way to interact with it is the on-demand web interface, which again, I'll show you a demo of that in a minute. So, we talked about 48 hours being the wall time, the maximum execution time. You can reserve a node. You can reserve a node, whether a GPU, an extreme memory, or a shared node, and you basically own that computer if your request goes through. So if you need something and you know it's gonna run for, a week, but you're gonna do it once or twice, you can reserve a machine to let you just do that. Again, that's where I say experiment with the lower level allocations, see what you need to do. If you can prove that your use case works, then they will probably give you a reservation for however long you want. The sense that I get is that not enough people use PSC, so feel free to ask for what you need. The final sort of feature that I wanted to mention briefly for Bridges 2 and some of the other supercomputers is gateways. So people have built sort of domain-specific web interfaces for complicated processes. So you want something really complex to happen, you can just upload a data file that you want to analyze, and it will run it for you. And it will take, like somebody else has built this thing. If I have time, I'll show you one of those too. And it's a lot easier to use than building a whole system yourself. Okay, we're running low. So I want to show you examples really quickly of each. This is from the documentation. So interactive use, if you log on via SSH to any of the nodes, you can just start it. This is a regular memory node, so you get 256 gigs of RAM, up to 128 processors. You just type interact, and then that'll give you a session time of 30 minutes. So basically you're guaranteeing that you're going to stop using this at 30 minutes. And then you can start another one if you want after that to keep getting billed. So that's a really simple way to do it. If you're going to run a batch script, you log in via SSH, you write a little job script, which again I'll show you in a second, but it's just one command line to batch with some parameters and then run your job. You do have to be careful with your specifications. It's a little easier to specify things here, or I should say more clear to specify things here than it is in the web interface. There's not much. One of our users accidentally used up, 100,000 hours in like 2 weeks in the summer. It was the whole thing. But you just be careful when you're requesting your resources that you're doing the right thing. Yeah.
So I just want to make sure, the 1 credit is 1 hour
In
on
PSC,
one node?
yes.
Okay.
Yeah.
I think one CPU, not one node.
Oh,
Each
one
node
core.
has 64 CPUs.
I see.
So usually it's like 1 unit is 1 core hour,
Right.
right?
Got it. Okay.
So this is what happened. So he chose accidentally 128 cores on one node for 2 days, and then we were out of money. So when you're looking at my script job, this is as simple as it needs to be. It's just a bash script, so a shell script like we talked about in our Linux session, and it gives you those specific parameters that you laid out in the command line also, and it just runs like a script. So it'll CD into here, which is your working directory. This example assumes that everything, your input, your application, and your output are all going to be in the same directory. So this is the simplest example that is there. And then as soon as you're there, it just runs whatever program you want. So if you have a Python script, you can do Python blah, 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 blah. You can run a shell script, you can do anything there that you can do from the command line regularly. All right, I'm going to show you this really quickly also. So using this is the on-demand web interface. It's fantastic. It's also a little bit slow sometimes. No saving the password. So there's a file explorer. You can view your home directory just by clicking through the menus. I don't have much in there because I'm not doing a lot of computation. But it's got all the file controls for uploading, downloading. Let's see. Yeah, so you can upload code or data right there. You can open this directory directly in the terminal, which is super nice. It's got a web-based terminal, right? So you don't have to SSH or anything. I probably mistyped it. Nope, there I am. Okay, so let's see. So these are my projects that I currently have credits on. And this is, that top one is mine related to my Campus Champion account. So I have another request in to actually get more credits since they don't seem to be paying attention right now. So wish me luck. And this is Stephen Deans because he's related to me as my Campus Champion sponsor. So I get to see what he's got there too. But at any time you can bring that up to see where you are with usage just by typing projects. Yeah, so this is just a little bit more specific details on the resources that you've used. You know, where your data is. Yeah, this is old stuff. So anyway, you can open a terminal right there, which is super nice. Let's take another look here. So in the on-demand dashboard, you can manage your files, you can open a terminal, you can look at your running jobs. So that's a whole job manager. It actually has an interface, so you don't necessarily have to write that SBatch script. You can run it through here with the point-and-click interface. Oh, that's another shell access thing. This is something that most people might be interested in at this point, though. They have built-in web interface for Jupyter Notebook directly connected to your account and RStudio server. So the one thing that I'll note about there is that this is a big system. I have a hard enough time keeping our 13 nodes up to date, but we're relatively close to that. This lags behind a minor version of two of some of the software. It took them a while to get R4 put on there. For example, we ran 3.7 for a really long time. So that's just one thing to be aware of. Yeah.
We still do the sort of personal package downloading in our own directory?
Yeah. Oh, so again, we're kind of at time, but there is a lot in the documentation that will tell you exactly how to do certain things. Yeah. So those are the basic 3 ways that you can interact with this system. And that's it. So that's not bad timing, actually. Any other questions?
So where would you say this should be kind of in the scope of the different computing resources we have?
So this actually just makes everything more confusing, right? Because now we have our campus cluster, we have the Azure, we have this, and as you saw, we have like supercomputers all over the world that we can use because of this. So a big part of my job is actually sitting down with you and trying to find out what you should be using. I should make a matrix up just for a choice. There's actually a flow chart on the wiki. Let me show you this for a second. Where is it?
Somewhere in the top.
What resources? Yeah, here we go. All right, so this is a great thing that you should review, and I'll share this specifically with the slides. But there are some flowcharts here that will help you decide. Yeah. So again, as I've said in every session, I encourage you to look through this wiki. There's lots of good information there, and our PhD TA Luca just added a whole bunch of new stuff for Azure, and it's wonderful. So I really encourage you to read through some of this.
I really like that. The beginning of build a big neural network. First question: do you really? Next yes. I agree.
Here you go. Don't have a computer. Have a computer in the shop. What do you do? So we're going to continue building this out.
That's great.
Yeah. But again, to your point, I encourage you to come talk to me anyway, so we know what to add here. And that's it. No chat questions, Mike?
I don't see anything.
Great. Thank you. Yes?
Yeah, I have several questions. So, yeah, so first, if the supercomputer is free, what's the credit for if it's already free?
Well, it's free, but you have to have credits given to you to use it. So they don't let anybody on, right? So you have to have a scientifically valid project.
So you're out of free, just request extra credit? Okay.
Yeah.
Another question is, what's the difference between a supercomputer and a cloud server? Because
Well, they're all just servers that are somewhere else, right? So there's no, the difference is that, like I highlighted here, sometimes it's managed, so you have to wait in line sometimes. You do have a fixed amount of credits to use before you have to either ask for new ones or give up. Now, the other interesting thing with the new system is that if you don't use all the credits, you can actually take them back from the resource that you requested. So you can use them for another resource. It used to be that you would get your allocation, and then if you didn't use it, that's tough luck. What else?
I think that's all. So, the high computing cost is very different from this and cloud, right? How is it different?
Well, it's different and similar. So it's similar in the sense that the way you